Today we will be discussing ratios. Okay, a ratio is a comparison of two things. Okay, so for instance, here, if we are comparing the number of squares to the number of circles, the squares there are 6, and the circles there are 3. So we would say there are 6 squares to every 3 circles, or there are 3 circles to every 6 squares, all right? And we can write this 3 ways, okay? We can write it squares to circles is 6 to 3. Now, order matters here. So because I said squares to circles, that means 6 needs to come first. We could write this with the word 2, 6 to 3. Okay, or 6, we could use a colon here, 3. All right, so the ratio of squares to circles is 6 to 3. And this is an example of a part to part ratio. Okay, so squares to circles. And then another one we could do would be circles to squares. And the order does matter here. So your fractions and these ratios are going to change. So circles to squares would be 3 to 6, okay? Or 3 to 6, or 3 over 6, okay? Now, we can also simplify these ratios to create an equivalent ratio. Notice 3 over 6 can simplify to 1/2. That means for every 1 circle, there are 2 squares. For every 1 circle, there are 2 squares. You can see that in this picture being broken up there, okay? And it's still true. In this picture, it's a 3 to 6 ratio, okay? But my equivalent ratio would still be there's a 1 to 2 ratio of circles to squares, okay? So just recognize that you can simplify these, as well as for our squares to circles. We could simplify that as well. Squares was 6 to 3. That would be it's 2, oops, a 2 to 1 ratio of squares to circles. Again, order matters. So if I'm saying squares first, that means my first number and my numerator has to be squares. And the circle with second, that means my second number or my denominator has to be the number associated with circles. Okay, so that is the most important part. Okay, now, so those are all part to part ratios. Now, if I was doing a part to whole ratio, that would mean I would be doing squares to total shapes. Okay, and the squares to the total shapes would be 6 to 9 because there are 6 squares and 3 circles. That means 9 total shapes. Okay, so that would be a 6 to 9 ratio. Okay, and again, that can simplify. It would be 2 to 3. Okay, it's also a 2 to 3 ratio. Okay, now you could also do a circle to total. Okay, circles to total would be 3 to 9. Okay, 3 to 9. All right, and again, that can be simplified as well. Again, the order matters. So the way that you say it matches the way that it is written. Okay, and again, can be simplified 1 to 3. Okay, there are, for every 1 circle, there are 3 total shapes. Okay, and you could also reverse this order and do total to squares or total to circles. All right, I'm just trying to show you there's lots of different ratios that we can write with that. The part to whole is looking at the whole group together as one of the numbers in our ratio, and part to part is just looking at pieces of what is pictured. Okay, and again, equivalent ratios exactly the same thing as equivalent fractions. Okay, ratios can be written as a fraction, so we we use that to write those equivalent ratios as well. Okay? Now, let's take a look at some practice problems that involve ratios. Make sure we understand our ratios. Amy has 5 chocolates and 7 pieces of bubble gum in her candy jar. So she has 5 chocolates and 7 bubble gums. All right. Dan has 3 chocolates and 5 bubble gums. All right. Amy thinks that the ratio of chocolates to bubble gums in both candy jars is the same because they each have 2 more pieces of bubble gum than chocolate. Okay. Is the same ratio of chocolates to bubble gum maintained? Okay. Now, again, Amy's ratio, again, they are looking at the ratio of chocolates to bubble gum. All right. So I'm going to look at that. That's where the question is, chocolates to bubblegum, which means Amy's is a ratio of 5 chocolates to 7 bubblegum. And Dan's ratio is 3 chocolates to 5 bubblegums. Okay, now is 5 to 7 and 3 to 5 equivalent? Well, no. Okay, because 5/7 is completely simplified and doesn't simplify any further. And same thing with 3/5. Okay, that is completely simplified. And 5/7 and 3/5 are not equal. Okay, all right. And both are, so again, justify my response, both are completely simplified. These are not equivalent fractions. All right. Let's take a look at Lily's here. All right, Lily's colored pencil box has 2 red pencils and 5 blue pencils. Joseph's box has 1 red pencil and 4 blue pencils. Lily thinks the ratio of red pencils to blue, so again, we're looking at red to blue, is the same because they each have 3 more blue pencils than red. Well, that's a similar explanation to what Amy used in this last section. Just because there's the same amount more doesn't mean the ratio is equivalent. So let's take a look. Red to blue. So Lily has 2 red and 5 blue, and Joseph has 1 red and 4 blue. Again, both of these ratios are fully simplified and they are not equivalent. Therefore, the ratio is not maintained. All right, and there's 4 more that you can try similar to that. Okay, and let's come down and take a look here. Tala is making some vegetable soup. 1 small pot of soup has the vegetables amount shown. If the large pot of soup holds 24 cups, how many cups of carrots will she need to keep the ratio in the large pot the same? Okay. Before we go on to this, I do want to mention that these ratios up top, we're looking at part to part, right? It was part of the candy was bubble gum and part was chocolates. So that's a part to part ratio. Part of the pencils in the jar were red and part were blue. So that's a part to part ratio. Okay, now the one that we're looking at here with this vegetables is it says Tala is making some vegetable soup. If the large pot holds 24 cups, it's not saying 24 cups of carrots and 24 cups of celery. It's saying total cups. All right. Now we need to keep the ratio of this. So this represents the small pot. All right. 1 small pot has the vegetable amount shown. So that's here. And we need to figure out for 24. So we are doing now a part to whole ratio here. All right. And it says how many cups of carrots. So our part we need is carrots to total. Okay. And actually, I'm going to use W for whole just because of the tomatoes. Okay. So here, the total number of cups in her soup is 2 plus 1 plus 3 is 6 total cups. So the small pot had 6 cups. All right. So the ratio of carrots to total is 2 to 6 in the small pot. And we are trying to figure out, okay, so if the large pot holds 24 cups, again, we put cups on the bottom, so we have to put cups on the bottom. Carrots is on top. okay? Which means we have to figure out, okay, so how many cups of carrots will we need? Well, 6 times 4 is 24. 2 times 4 is 8. So we will need 8 cups of carrots, okay? All right, so how many cups of carrots will she need to keep the ratio the same? 8 cups of carrots. Okay, let's look at another one like that. Riley needs cupcakes for her class party. One small box of cupcake contains the flavors shown. So again, this is the small box, all right, is represented right here. A large box holds the same ratio of cupcakes. If the large box holds 40, so again, our total is 40 cupcakes. How many red velvet cupcakes will there be? All right. So same thing here. We're trying to figure out, okay, for red velvet, all right, there are currently 1 red velvet in the small box, but what is my total? I can get that by adding these. 2 plus 3 is 5, plus 4 is 9, plus 1 is 10 is my total. So 1 out of 10 is red velvet. 1 times 4 is 40. 1 times 4 is 4. So we have 4 red velvet cupcakes will be in the large box. Okay? There are 4 more that you can do like that. Okay? Last type of problem we are going to do today is Gianna is making up bags of fruit for her soccer team. Each bag contains 2 strawberries, 4 blueberries, and 3 raspberries. If she used a total of 16 strawberries, how many raspberries did she use? Okay, so we're looking at, okay, so each bag contains 2 strawberries and 3 raspberries. So this is looking at a part to part actually. It throws that word total in there, but because it's just looking at strawberries, it's not saying total fruit, right? The total strawberries, she's saying in all the bags. That's why they used that word total. Okay. So we can't just see words and think that it indicates one thing or another. We have to make sure we understand the context of the problem. Okay. So again, strawberries to raspberries. And Gianna has 2 strawberries for 3 raspberries in the small. And if she uses 16 strawberries total in all the bags, how many raspberries would she have used? Well, 2 times 8 is 16, so 3 times 8 is 24. So she will have used 24 raspberries. All right. The owner of Pizza Palace has a deal offering 1 free order of breadsticks with 3 pizzas. Okay. 1 free breadsticks with 3 pizzas. If 24 total pizzas were sold with his deal, how many orders of breadsticks were given away for free? So 1 breadstick for 3 pizzas is how many breadsticks for 24 pizzas? Okay, this one seemed a little bit easier. They didn't have any extra numbers that we didn't use. Okay, so we multiply 3 times 8 equals 24. So 1 times 8. So that means there are 8 free boxes of breadsticks. Okay, there are 3 more just like that you can try on your own.